Hello. Today we'll be talking about data definition language statements. This is Oracle SQL. We'll be using Live SQL, a cloud platform that helps us to query existing schemas and database objects under those schemas. So mainly we'll be talking about what data definition language statement is, how it differs from data manipulation language statements, and specifically, we'll be talking about the three common clauses that helps you to create database objects. So create, alter, and drop. So we'll be using these three clauses in different database objects as a sample. We start with table. We'll spend much of our time on like defining table structures, altering it or modifying it, and then dropping table structures. And beyond that, we'll be creating views and sequences. Let's start from the definition, DDL. What do we mean by data definition language statement? So if you heard about DML, for instance, DML is basically data manipulation, right? So the keyword here is data manipulation. So this is its center or its focus is data. But if you come to this one, DDL is all about definition. That means its focus is on the structure of the structure of the database object rather than the data it holds. Okay, so data definition language statements are statements that helps you create database objects. Okay, that helps you modify database objects. We use a clause alter dbos, and finally delete, or in its real term, drop database objects. So this is a statement that helps you to create structure, modify structure, and delete structure or drop structure. Okay, so this is one. So it's mainly different. It has a main difference between there is a main difference between DDL and DML. DML is data centric. It manipulates data. It inserts data. It deletes data. It updates data. But when you see DDL, it's a definition language statement. That means it creates data structure, it alters data structure, and it drops data structure. So the operations you do with DML are reversible with some sort of flashback or with by creating some sort of synergy between undo tablespace and redo log files. But when you come to DDL, DDLs are auto commit operations. That means you cannot easily reverse what you have done using these statements. Okay, so we have been talking about database objects, right? So there are different database objects. For instance, table is one. When you say database object, it's an object that manipulates data or it holds data. Okay, so table is one of them. We do have other database objects like view, index, sequence. Okay, record, for instance, is another database object. Cursor is another database object. You better read about this. Okay, database link is also another database object. If you go to PL SQL or you can also call it PG-SQL in case of PostgreSQL. There are different program units like procedures, you can consider them as database object, functions, objects themselves, so for object-oriented database. We have package, okay? And different database objects are there. So for today's session, we'll be using three database objects. The first one in the most important one is table. The second one will be view, and the third one is sequence. Table is a database, it's simply a database object that helps you store data in rows and columns. Okay? In rows and columns, it helps you to store data. So table has different characteristics. There are different syntaxes to create table. We'll talk about that one later. View is you know, a DBO that provides access to your table or tables. Okay, it might allow you to access one or more tables in general. So usually views are read-only database objects, but there are some conditions where you can also insert to tables through views. The main purpose of these views is, the first thing is performance, okay, and the second thing is security. From the performance perspective, for instance, whenever you want to access data from table, you have to parse your query. This process is called parsing, so which takes time. Okay, the main issue here is time. So view eliminates or avoids this repetitive parsing for the same type of query. So if you create view, then you are creating the parse equivalent of that query. So in a way, whenever a new query with similar requirement comes, then this parsed set of instructions helps you to avoid time complexities, larger time complexities. So that's from the performance perspective. From the security perspective, views helps you to mask what is inside your table or what the structure of your table is for real. So views are there as a middleware between your real database objects and and then whenever you access data from your database objects, you will not be able to see the attributes name, you'll not be able to see how they are organized, because views are there to change its structure and naming in general, and then give you a masked and transparent view of the database object. Sequence is another database object which we use it mostly for auto increment and series and sequence type of data structures. These are again database objects that allows you to count something, okay? To count sequence of phases in general. So for instance, if you want to insert a new ID to a new tuple whenever it is getting inserted, then you may attach a sequence value that increments over time upon every insert, and then this sequence value will generate incremental values for your one column. We'll see this one practically, okay? So now let's dive into the experimental part of this discussion. So I said there are three major instructions or clauses for DDL, data definition language statement. The first one is create, then alter, then drop. For all types of database objects, these are applicable. So let's start with table then. How do we create table structure? Okay, let's start with the syntax. The syntax, there are different, by the way, different syntaxes to create table structures, but one of the common syntaxes is create table. Okay. Create table. Then you will have table name. Okay. And then you'll have this one. This is simply an MPT constructor to create table. So inside this, you will list of columns you need for the table. So here you will have, sorry, here you have column, and here you have data type. Okay, I will talk about this one in detail. And in case if you have to set constraints, here you will have constraint. Then comma, second column name. Okay, again data type. Constraint is optional. Okay, constraint. The same is true for all other columns. So this is the structure you use to create table. So here there are important concepts you need to know. The first one is data type, right? So data type is a domain of a column or an attribute. What do we mean by a domain of a column or domain of an attribute? For instance, say we do have a column named first name, named first name. So usually first name is represented with this data type or domain called uh, alphanumeric, right? Usually it's alphanumeric. So most of the time people use alphabets, A to Z alphabets, but sometimes they might use numbers in their name. So it's okay with that. We are okay with that. So we say it's alphanumeric type of data, the data we call first name. When you go to another data type, for instance, date of birth. Date of birth, if you see date of birth, it has a structure which looks like date. So we call the domain of this date of birth is date type, because we usually write date of birth in like, for instance, we might write it like August 2024, or sometimes we might write it like 09 01 2023, something like this, right? There are different ways to write dates. So this kind of constraints uh, tells you that it's a date in date format. So for date of birth, you do have date format. So the other one, for instance, if you have number of children as a column name, then this is going to be number, right? So in general, this is what we call domain of attribute or data type. So whenever you say first name has alphanumeric type of uh, data, that means anything, okay, anything that is doable to alphanumeric character is doable to your column. That is the semantics. Column. That's the semantics. So we do have data type for each attribute, for each column. And if you specify, for instance, number for number of children, then someone else cannot insert character type data to this attribute or to this column. So this is also another way of constraining the type of data this column has to accept. So that's one important concept. The second important concept here is constraint. Okay, constraints are simply functions, by the way, functions abstaining, or the right wording would be prohibiting some sort of values and relationships to happen. Okay, some sort of values or relationships it prohibits. For instance, if you set first name to a constraint called not null, then no one can insert null value to this. Sorry, no one can insert null values to this first name column. So there are different constraints, by the way. Not null, as I already told you, is the first one. We do have check constraint. Okay, we do have unique constraint. I'll talk about this one. We do have primary key constraint, and we do have foreign key constraint. So these all are constraints that you can impose on your tables or database objects. So not null constraints, what it does, prohibits null values from getting stored. That's the first one. Check, it has this check syntax. Inside this, it accepts condition with some sort of comparison or relational operator. So check condition, then it checks whether the condition is met or not. Okay, that's its purpose. If it's not met, it will reject any operation that's coming towards this against this check operation. Unique is kind of identity constraint, or as the name indicates, it ensures uniqueness. Okay, uniqueness. I'm having issues with the keyboard. So it ensures uniqueness of data. Okay, wherever you define this unique constraint, then that column will not have repeated values. Primary key and unique key are the same with unique constraint, but the difference is primary key does not accept null values. Okay, that is the first one. The second one, only one primary key per table. But when you go there, many unique key per table. Okay, yeah, many unique key per table. It also accepts null values. Okay, when you come to foreign key, so this primary key is more constrained form of unique key. Okay, when you come to constraint foreign key constraint, we call this one referential integrity constraint. Okay, this means you may have table A or table 1, and you may also have table 2. Then if you want to create like referential relationship between these two tables, the only way to do that is to create some common column in between these two tables. This common column in between these two tables, we usually call it join column. Okay, if you haven't watched my video on join or multi-table queries, you have to watch it now. Then we have join column. So this join column is pk in home table, in home base or in home table, and it will be foreign key in other table. Okay, so if you want to establish this kind of relationship, referential integrity constraint or foreign key based constraint, then you use foreign key constraint. We'll see how we can do this thing in detail. Okay, so we have seen how we can create table. Table can be created using this command, create table, table name, then this brace will be open, parenthesis is open as you can see, then columns data type, then if there is any constraint, you can add that constraint, but as I told you, it's optional. Let's create one table. Let's have one command, create table, say person. Okay, with some values. So I'm going to define the values of the columns by myself. So let's do this. Create table as per the syntax. The name of the table will be specified here, and semicolon finally. And inside here, we'll have list of columns that are relevant for this person object. So we'll have person ID. We need to identify it, right? So we'll have person ID. The type of person ID should be alphanumeric. So we have data type called varchar2. Let's give it 20 characters place. Okay. The person will have first name, right? Again, varchar2. Okay. Then let's give it again 20 characters position. Last name is also must. Okay. And let's change another data type. For instance, what do we need? Person height, for instance. Person height, right? It should be number. And read about these data types, by the way. Number should have some precision points. So let's do this, like 2 precision point. the person again should have weight. Okay, let's do the same. I think that's enough for now. So now let's create this table. We said create table, table name, column 1, data type, column 2, data type, same is true. So we do have two data types here, varchar2 and number type. For the varchar2, we gave similar values, similar length values for the characters of these columns, which is 20. For the height, again, we gave the same precision point. So it's kind of floating point or double type data type for height and weight with 2 precision points. So let me run this one. It says missing right parenthesis, right? So I missed one column in here. So this one, the last one, doesn't need any column, any comma, sorry. Okay, now it says table is created. We can go back to our schema directly. We created table person, and clicking on my session, you can simply see, sorry, my schema. Clicking on schema, you can simply see the person table created. Okay, as a valid table. You can see the column name, type, length, precision. You see, the scale, everything is here. We haven't defined any constraints yet, right? When we define constraints, you will see constraints here. So let's get back to the SQL worksheet. Okay, so now we have created our table. But what if I want to drop this same table? So in order to drop or delete table, the command you use is drop table name. Okay. Okay. I just deleted the table. Now let's go back to the table creation command, and I want to now create table with constraints. Okay, with constraints, with different constraints. So I only have to modify the existing table definition. So let's do this. Create table person. Person ID is, you know, kind of unique thing. It should be unique for everybody. So two person cannot have the same ID. So for that, let's add one key. Let's call it primary key. So here, what I'm saying is person ID cannot be repeated in this table structure. So I say the constraint is primary key. And again, if you want, for instance, the height of any living person cannot be, say, what is the maximum height we can tolerate. It should be, I would say, the SI unit say it's meter. So let's say it should be less than 3 meter. Okay. For the weight, again, we can define some check constraint. Let the weight be let it be in kilograms, and it should be less than 600. Okay, fair enough. So now we have primary key constraint, and for the last name, let me define not null constraint. This is how you define constraints, by the way, in simple form. So when I create this table, I have dropped it so I can recreate it. Okay, table created. Let's go back to the schema. Let's see it in detail. We have person table. As you can see, everything is there, but from the constraint side, you can see last name has not null constraint, height has check constraint, which is height less than 3. The same is true for weight, and one column which is person ID has primary key constraint. So now let's try to insert something repeated to this table. So you should be aware you cannot add the same value to the same column if it is twice if it is primary key. So let me insert into person. Okay, so the table, the column names are person ID, first name, last name, height is there, weight is there, and values What are the values? Okay, let me give it, the first one is alphanumeric, so it should be string literal 1. The second one, let me use Ethiopian name, okay? Ababa. The third one, okay, let me start it in a new line. Ababa, the last name is Kabada. Height, let's say it's 2. And weight, let's say it is, I think 80 is a common height. So let me insert this one here. So one row is inserted. Let's check what the table holds from person. Okay, you see, 1 Abebe Kabede 2 AT, it's inserted now. So what I mean by primary key is that person ID cannot have another value which has the same value as this one. So let's try that for another person. Let me call the other person's name Warku and his last name Lemma. Let them have the same type of thing. I think one thing we forgot is yeah, we haven't forgotten that one. Okay, we have already created it here. Yeah. So it's Warku Lemma. It's different name, but the what is that one? The height and weight are the same as the previous guy, but the ID, which is supposed to be unique, is not going to be unique after this. So let me try to insert this one. You will see a violation error. See, unique constraint, you have violated some sort of uniqueness constraints, it says. So in that case, if I change this one into this, look, so now there will not be repeated column value for the first one, so it inserted. Now this is how primary key operates. Okay, so we do have two users now. Now the other one is last name, right? Last name is not null value, so last name cannot be null. So let me try to insert another guy with null last name. So let me delete last name from here, okay, and let me also delete last name from here, and let me change the person's name to some other Ethiopian name, Chaltu. Okay. Then ID is 3, which is unique. First name is Chaltu. Last name is not there. So all other values are the same. Let me insert it. Run. It says cannot insert null into person.last name. You see? Because last name is what? Is said to be not null. So in this case, I have to write last name to make this one happen. And here also I have to write the last name of Chaltu, which is Kabeda. I like these names. So now we were able to insert, right? Okay. So Chaltu is in because we satisfied the constraints set. So we try to check whether this table accepts repeated values or not in case of person ID, accepts null value or not in case of last name. We haven't checked with this one, so let me check with this one again. So let me try to insert some value greater than the constraint set by the check constraint. So let me try to add another person. The person name shall be Chala. His last name be Hunde. And the constraint for this one, for the height, is 3, right? It should be less than 3. So let me make it 4. Now when I try to insert, you will see a check constraint violation. You see? Because this is 4. A person cannot be like longer than 4 meters, 3 meters actually. So that's what it says. So, but if I do it like 2.5, this constraint should accept it. See? So if you see, run. So we do have Chala Hyundai with a height of 2.5 meter. Okay, so now we have seen how we can create constraints and how we can, how do they help us, right? So the other one, a bit advanced way of creating table with constraints and subqueries. I'm going to show you this one with subquery. Okay, so now let me drop the previous column, drop column person, because I'm not going to create new table. We're going to work only on table person. It's not column, right? It's table. Yeah. So drop table person is dropped. Now let me copy this and create the constraints in different format. Actually, I shall copy this one because it doesn't have any constraints, right? So the first one, I want to create primary key for this one. So the way to do that is we can say constraint, the name of the constraint. For instance, const pk for the table person ID. Okay. Then the constraint type is primary key, and the constraint column is person ID. Here I defined this one. This is very important because if you want to define two columns as a primary key, this allows you to do that. Look, comma, first name. In the case of the previous one, you couldn't. This is one. The second one, if you want to create unique key, for instance, I want to create a unique combination of first name and last name, so I can do that. Another way is without writing constraint, even we can do that. Okay, we can say unique. The columns are first name, last name. Mind you, I can still do and name this one constraint, name a some sort of name, unique. This is also possible, okay? But I like to do it simply like this. Whenever you want to access the constraint letter independently, then you should use this kind of constraint naming. Otherwise, you can simply define constraints like this. So, but for constraints like not null, you can simply do this, okay? For instance, we might need last name not to be null, so I can define not null for this one. So when I create this one, it's the same type of constraint, but with different requirements. So when I, for instance, if you see this, go to schema, let's see person. If you see this, for instance, we do have primary key constraint for the first name, and what was the other one? Person ID, right? Person ID and first name, which is primary key constraint. Unique key constraint, first name and last name. There is also not null constraint, as you remember. So this is how constraints are defined on your target table. Okay. Now I just showed you a different way to create constraints. I'll get back to you with a special type of constraint called foreign key constraint. But before that, let me show you how to create table with subquery. Okay. In order to create table with subquery, you simply do like create table, table name, then use as and a query here, any type of query. Okay. For instance, I want to create or clone table, say, what have I created? Person, right? But it doesn't have any data. So for that, I will choose from HR schema, employees. We do have HR schema in this system. So I can say create table, employees, as select all from HR.employees. Okay, so in this case, I can, if you let me show you what is inside this HR.employees first. Okay, So HR.employees is this table with different columns and more than 100 rows. Okay, so I'm going to copy this whole structure and data to my new table called employees. But this employees, HR.employees belongs to a schema called HR, not my schema. So I'm cloning this one to employees. When I do this and get back to my schema and see, you will see a table called employees, which is created as an exact replica of the table I have been targeting. See? Columns. Yeah, this is it. This is it. Okay, let me get back. So this is a common way to create tables. A common way to create tables. So now let me get back to constraints and show you how to create a foreign key. Okay, foreign key. So for that, I need to have two tables because foreign key is a way to create referential integrity, right? So for that, I need to have one table as a base for my foreign key and another table as a destination for my foreign key. So for that, let me create two things, teacher versus student. So as you know, teacher, for instance, has uh, ID, name, and course, right? So I will not more normalize this table. Student will have, again, ID, name. Student also attends for some course, but it's better to link him with a teacher who has been teaching him. Okay, teacher ID. Now, let's create a relationship between this teacher and this student. So the first thing we should do is we should be creating a table called teacher because teacher is the one who will be providing a join column for the second table. So create table teacher. Okay, here. Then we have teacher ID. Sorry, let me make it more readable. Teacher ID, let it be number. Okay, and let it be primary key because we need it as a foreign key for you to refer some columns as a foreign key to another table. You have to make it primary key. Okay, then let's say he has name varchar2 40. Then let's say he has course, or let me call it number of courses. Okay, because we cannot list all courses here, so let it be number. Okay, now I can create this one table called teacher. If you see table, by the way, if you want to see table without going to anywhere, you can say desk table name, in our case desk teacher. Then you see here we do have teacher ID, which is not null because it's primary key, name, and number of courses. Now let's create another table called student. So create table student, right? Then let's go down and the first one should be student ID. Student ID, let it be number, just for ease. Okay, you can make it primary key or not, it's not our target now. Student name is there, again varchar2, let it be 40. And the last one is let me link it with the teacher who is teaching this student. So let me call it teacher ID or whatever name you can. You can simply say ID if you want, but to give insight to the reader, we better say a name that reflects what it is. So now we are going to define a constraint. So we can say in a very formal way, constraint, foreign key constraint for the student and teacher. Okay, this is just name. Foreign key. The foreign key from this table is what? teacher ID, but it references to another table, right? References another table. What is the table name? Teacher table. And from that table, what column is it referring to? Teacher ID column. See? This is how you define foreign keys. Let me run this one. Look, it says table created. If you get back to the schema, you see student and teacher. If you go to student, you can see the different columns we created. And here, if you see constraint, we do have one constraint called foreign key. Its relatable table is teacher, right? You can see where teacher is, the constraint columns are also there. Now let me get back to the student column, and then let's try to insert some data to student. Mind you, we haven't inserted anything to the teacher table. So now with that, let's insert into student table. Insert into student, okay, and values for all those three columns. Its first one is number type, student name, let it be Abebe Kabede, okay. Last one is teacher ID. We haven't mentioned any teacher ID on the teachers table, so let me say it's 2. Okay. When I try to insert this data to the student table, there will be a foreign key constraint violation because these 2 should be listed inside the teacher table as a teacher ID. Okay, but since there is no such kind of thing, we will see error when we try to insert this data. Look, insert integrity constraint, it says, because it's foreign key constraint. So how do we solve this? First, we have to insert some sort of data to the teacher table, okay? Into teacher and values. The first one should be ID. It should be 2 for this to work. And the other one, teacher has name and number of courses. So name is character. So name may be, Zalalem, for instance. Okay, Zalalem Tasfai. Okay, then number of courses. This guy might be teaching 3 courses. Now let me insert this one. Since this table doesn't have any dependency or constraint, this should work, right? So now we do have data inside teacher table with ID 2, with teacher ID 2. So when we try to insert student value with teacher ID 2, this student table checks whether this 2 value is available here or not on the teacher table. If there is same type of data there, then it will allow us to insert. So now see, it will allow me to insert. Is it? So when we check the data, for instance, select all from student, you will see some data. This happened because we previously inserted a teacher with ID 2 to the teacher table, as you can see, whose name is Zalalem Tasfai. So this is how the foreign key generally allows us to keep referential integrity of your relational database objects. Okay, that being said, let me show you the second command of data definition language statement, which is alter. So alter helps you to create many things actually. The first thing it allows you to do is to add column or to add constraint to your table. For instance, we do have table called student, right? We do have table called student. If you describe it, it has student ID, student name, and teacher ID. What if I want to add some column to this student that says year, for instance? So I can do that. How? I will do alter table. The table name is student. Add Okay, now I will add the name of the column. Now I say the name of the column is year uh, of graduation, for instance. Year of graduation, its type is date. And let me set it as not null. I cannot set because there is already null value. So let it be like this, for instance. So this one will add another column called year of graduation, which is date type. Table is altered. When I describe this table again, you will see the new column added to this one, which is year of graduation. And when you see, for instance, the data in this one, okay, look, the year of graduation is null. Okay, so this is one. The other one is, for instance, if again let's add another one. For instance, I just alter table student, add what other attribute could a student have? It might be year, for instance, year of or date of birth. Let me call it date of birth. Date of birth. Let me add one constraint here. It's date type, but the constraint I want to add is default value. Default value shall be, for instance, it should be 0. It should not be null, for instance, or it should be, say, 18, because it's 18 is the default adult beginning or entry point age, right? So let me do this. I'm adding default for the date of birth column. Oh, sorry, date of birth. So it's not age, right? I have to add something. The default date of birth should be, for instance, current date. If it didn't enter, so this date is the current system date. So let's do this. Table altered. Let's describe the table. Then we have date of birth, date type. So let's see the data, existing data from a student table. So you see, since I set the default value date of birth to sys date, it will not be null. It will set all the previous values, all the previous null values of date of birth to the system date. Okay, this is what I wanted to show you on the second alter command. Okay, now I want to modify that. I want to modify some of the columns. For instance, here I do have date of birth column, but I want to make it not null. Okay, I want to make it not null. How can I do that? There is a command called modify. So alter table student modify. Then you simply modify the type of column you want to modify. So it's date type. Okay, and let's say it's not null. Okay, so now when you run this one, you will see sorry, let's run the data. Here you can see this, but from the disk, sorry, I haven't showed you that one. From the disk you see date of birth is set to not null. So this is basically how you modify um, your existing columns. Actually, you can set different primary key, foreign key, any type of constraints for that specific column or for the whole table as you want. Okay, as you want. So the other one is renaming. Renaming column. You can say like this. Here, for instance, alter table student rename. We need date of birth to, for instance, what is the other name for date of birth? Birth date, right? To birth date. This is how you rename your columns. So there are different things you should do. This should work actually. Maybe I'm working on live SQL, so it has very constrained set of commands or interpreter capability, but this one should work. Okay, so this is how you manipulate your table structure. It's not the data, but the table structure using alter command. So that being said about DDL or table, especially we have been talking about many things, right? The first one, how to create table with simple columns, how to create table with constraints, how to create constraints separately, how to alter tables, right? We have seen that. When we say how to alter, it might be adding columns, adding constraints, adding or modifying data type, modifying the name or renaming the name of the column. Different things could be done. Now let's see the other data type, data object, actually, database object, which is view. So I will not be diving more into this one, but I will show you how to create and drop this. So view is, as I told you, is a database object that serves as a performance engine and also a security mechanism. So in order to create view, you have this syntax. The syntax is like create view as select operation or as query. Let me say this one is query. Okay. For instance, we have table employees, right? If you want to create, this is employees, right? This is, I think, employees with various columns. I want to create a view called KYC with only employee ID, first name and last name. So that way I can allow others to only see this KYC information of my whole table. So this is a way to mask and also increase performance of read accesses. So create table, create view, right? View name is KYC as select employee ID, first name, last name from employees. Okay, so this is a view being created. So view is created. Let's go back to our schema. Let's see where the view is. Okay, so you can see KYC is here as a view. Then if you see here, employee ID, first name and last name is there. So every specific structure definition or metadata is also there. So whenever you want to access data, for instance, you can simply say, okay, you can simply say select all from KYC. The same way you access your table. See? So here you are. You have all information, but specific to first name, last name, and employee ID. And if you want to drop it, you simply say drop view KYC. It's the same, right? The same way we dropped table person. Good. The last database object I want to show you today is sequence. Sequence, as I told you, it serves as an incrementer or a value counter. So the syntax for sequence creation is like this. Create sequence name is there. Okay. Then you say start with value. Okay. Where should this sequence start counting? Is it from 0? Is it from 1? Is it from 2? You set value. Increment by, this is offset setter. That means after saying 1, what should it say? Like 2 or 3 or 4? So by how many numbers or offsets shall it jump the counting? Again, you have to set value here. You can say, you can set cache size. Okay, cache size, how many memory area should it hold? Some value here again. Shall it circulate or shall it be circular type of sequence? That means whenever it reaches the maximum value, should it be starting from 0, or shall it continue? So cycle is there for that. Or if you don't want, the default is also no cycle. No cycle is there. The other one, max value, you should set sometimes. For instance, if it is like if it is 100,000, so you should stop it there. Again, mean value, where should it start counting? Value should be here. So let's experiment this one. I want to create a view, sorry, a sequence called, say, counter call. Okay, I want to create this sequence, and I'm going to use it to create another table. So let's do this. Create sequence. Sequence name is counter call, right? Start with, let's start with 1. Increment by, the default is also 1, but let's say 1. No cycle. No cycle is like you don't want it to cycle back to 1 when it reaches some value. So max value, let it be, I think max value is like this. We will correct it later. Anyway, max value is like, say, 100, and let mean value be 1. Okay, what else? Cache, we haven't defined cache, right? Cache is, let me cut it here. Let's say cache is 40. Okay, that's enough. So I have created, I'm creating sequence counter call. I might have issues with the max value and the mean value syntax, but we'll correct it. It seems I'm also having some issue with the network. Let me restart it. I'm having issues with network, I guess. Yeah. I think it's not network issue, it's Oracle issue, I guess, because some other websites are working. Yeah, it's working, see? So this platform is having issue. Okay. Yeah. Okay. I guess I'm having issues with the live SQL platform. So it's okay. Just let me summarize what I've been talking about. Let me go here maybe and write it in a new page. This is the manual I have been using, not in real time, but I usually use this manual. Let me go. Oh, okay, I cannot edit this one either. It's okay. Maybe I will cover sequence in a separate DDL related yeah DDL related a video. But for now, I think it's enough. We shouldn't be spending much time on this. So create sequence is there for incremental update of column and values. You can create them using create sequence command. You can still alter them, drop them, but in order to access the current value of sequence, you have to use sequence name dot curval, currval, and if you want to increment the sequence by some value which is set during the sequence creation, then you have to say sequence name dot next val without any space. So that's all. Thank you for attending. Bye.